Alright guys, we're going to take a look at the last piece that's going to cover this unit, and it's the areas of circles and sectors. We're also going to take a look at segments as well. So let's get started. The sector of a circle is defined as the region bounded by an arc of the circle and two radii to arc end points. Okay, so a sector of a circle is a region bounded by the arc and two radii to arc end points. So if we take a look down here, I have two radii that is bounded by the end points of this arc, and that becomes a sector of the circle. So we also, let's just start with because this is going to lead into our formula for the sector. So we know an area of a triangle, or an area of a circle. We know its area equals pi r squared. Used it a million times. So let's practice real quickly how to find certain pieces when we have some information given. So it says, hey, find the indicated measure. I want to find the area of the whole circle. So area equals pi r squared. When I use a formula, I should start by writing it down and then show the substitution. 4.2 squared. You need to get in the habit of showing an exact answer and then approximating it. So 4.2 squared, we're going to get equal to 17.64 times pi meters squared. That's my exact answer. And my approximate area then, when I put in this into my calculator, gives me 55.4 meters squared. So that's the plain old area formula for a circle. We know how to use that. So we're looking for the diameter and we're given the area. So I know that area is equal to pi r squared. Substituting in the pieces I know, 201 is equal to pi r squared. I got to start solving for r so that I can figure out the diameter is double my r. So I'm going to divide both sides by pi equals r squared. So in order to get r by itself, I do the inverse operation, which means I square both sides. So I know r is the square root of 201 over pi. I'm not going to approximate it at this point. I don't do any approximations till the very end. But that's just the radius. We know the radius is half of the diameter, so the diameter is twice the radius. So I know that the diameter I'm looking for is 2 times the radius, 2 times the square root of 201 over pi is my exact answer, and that's in inches. And now I can put this in my calculator. Be careful with your calculator entries. You may need your parentheses in here, so you also may need parentheses under your radical, depending on what calculator you're using. So when I put that in my calculator, I get D is approximately 16 inches. And that's your diameter. 16, if I put 16 squared, I'd have 16 squared times pi in my calculator. I'm going to get pretty close to 201. So that's how I can go back and check, make sure I have this right. Okay, so knowing our area of a circle leads us into the area of a sector. And again, the sector is like a wedge inside my circle. So we want to find the area of the piece of pie that we're going to eat on Friday. So let's look at some naming. So if I want to name a sector is named from an endpoint to the center to the other endpoint. So I am writing sector, and unfortunately there's no abbreviation, that APB. Or I could call it BPA. So that's sector, so I know it's the whole wedge. We also know that a sector is a fractional part of the area of entire circle. So it's a fractional or proportional, it's a ratio of the entire area. So we looked at this when we were looking at segments yesterday. So let's take a look and see what the formula is. So I know the area of sector, this is sector APB, is is the proportion or the ratio of the entire. So I need to find the measure of arc AB. That's the endpoints of the arc here over 360, so that I get the ratio of that arc to the entire 360. And remember, measures are not lengths, they are degree. And that's why we put it over 360. Times, since we're dealing with area, times the area of the whole thing, so that I can set up my proportion, the piece as it is to the entire circle. And then you just substitute in the pieces you need. So let's go find some areas of circle. Find the area of the sector. So the sector is the wedge formed by angle RQS. Okay. We know that the central angle gives us our measure of our arc. So I know my measure of my arc is going to be 63. If this is 63, it wants us to find the sector's form. So I'm going to have a small sector that's shaded. But this angle also forms this large sector, so this other sector here. I can easily find the small sector area and subtract it from this the circle's entire area to find the large sector area. So let's find the measures of the minor. We don't need the major arc, but we can take a look at it. So I know the measure of RS, arc RS, is in degrees, so we know that it is equal to 63. I want to find the small area so that I can subtract it from the entire circle to get the large sector. So I'm going to start with the area formula for sector is equal to the measure of RS, so it's equal to the arc's measure over 360 times the entire area. So it's a proportion of that. Substituting in the pieces I know, the measure is 63 out of 360 times pi. They gave me the radius of 5, and we'll call that 25 because it's r squared. I need to multiply 63 times 25 and divide that by 360 to start simplifying this. My calculator may or may not give me a decimal. If it does, use your math fracking to see that the exact answer is 35 over 8 pi. What's our units? We don't have units, so we'll call them units squared. So the area of this pi piece is 35/8 pi units squared. So we can approximate that as, go up here. Area is approximately, in my calculator, we get 13.7 units squared. Okay? But all we've done is found the small wedge. So we need to find the large sector by taking the entire circle area and subtracting the sector we just found. So let's find the large. So here I'm going to label this small, so we know that was a small sector. So I want to find the area of the circle, and it's a dot inside of a circle, and we're going to call it circle Q, equals pi r squared, which means I've got 25 pi is the area of the entire circle. So I want the area of the entire circle Q subtracting the area of the small sector to find the large area. So we know that we have the area of the entire circle is 25 pi, and I want to subtract the exact answer first, so 35 over 8 pi. I need to find the common denominator by 8, so I multiply 25 by 8. 25 times 8 minus 35 is going to equal 165 over my denominator of 8 pi units So this is my large sector, units squared. So I can approximate that, which is approximately 64.8 units squared. Alright, let's see. You guys have 1, 2, 3 of those to try. Come back, check your answers. Okay, there are your answers. Make sure you check those. If you got them wrong, rework them. Come in with questions tomorrow. Alright, let's take a look at some more stuff. So use the diagram to find the area of this circle C. So I need to find the area of the entire circle. So we need what to find the area of a circle? That's area of a circle is pi r squared. So I need to find pi r. So I can solve for r. So let's use that method and solve for r. I know that the area of the sector ACB is equal to the measure of the arc AB over 360 times the entire area of the circle. Substituting in the pieces I know, they gave me the area is 22 equals the measure of the arc is same as its central angle, so the measure of the arc is 45 degrees over 360 times pi r squared. Okay, so far so good. In order to get r by itself, algebraically, I'm going to multiply 360 over 45 pi on both sides. I am multiplying by its reciprocal so that it cancels it out. So I took the reciprocal, 45 times pi is 45 pi over 360, so I'm going to multiply by the reciprocal on both sides. I end up with r squared is equal to 176 over pi. So that must mean I have to take the square root of both sides, so that r is equal to the square root of 176 over pi. Now that I know what r is, I can find the circle. So the area of circle C is going to equal pi r squared. So that means pi, and I'm going to do the square root of 176 over pi, all of that squared. Now remember, square root and squaring are inverse operations, so that ends up canceling out the root and the square. So I end up with an exact answer of 176 times pi over pi, because I'm just multiplying straight across. Well, the pi's cancel out, so I end up with 176. And we're looking at areas, meters squared. Okay, so it's mostly the algebra that's going to mess you up, so keep an eye on what the rules are and make sure you're going step by step. Alright, we want to find the area of this shaded area here. So we're doing some carpentry, and for whatever reason I need to cut out this middle thing. And so I need to find the entire area and then take away the pieces of the area I know. So if we know, I'm going to set it up. I want the area of the rectangle, the big rectangle, take away the area of the circle, take away the area of the small rectangle, because I can take this piece and make a circle out of it, or a half a circle, and a rectangle. So I'm going to do a half a circle here. Take away a half a circle, and then take away this rectangle piece up here, and I'm in business. So the area of the big rectangle is base times width, or base times height, or width, length times width. So this whole thing is 7 times 11. So I'm at 11 times 7 minus 1/2 the area of the circle. So this area of the circle is pi r squared. Pi and r must be 1.5. So I'm going to have over 2, up here I'm going to have pi and 1.5 squared. And then I'm going to take an area here. So I'm getting rid of this top little rectangular piece, which I know is 3 by 3, so it's really a square. So 3 times 3 is the area of that baby square. So then it just becomes about the math. So I know 11 times 7 is 77 minus 1.5 squared divided by 2 is going to equal 1.125 pi, because the pi doesn't go anywhere, minus 9. 77 minus 9 is 68 minus 1.125 pi. That is an exact area, so we're looking at inches squared. But that doesn't mean anything, so we want to approximate it. 68 minus 1.125, oops, 68 minus 1.125 in my calculator, 12.155, is approximately 64.5 inches squared. All right, you guys try the next two. Okay, there are your answers there. Rework them if you didn't get them right. Come to class with some questions. That would be awesome. All right, our last little bit deals with segments. So we're going to have to get the vocabulary down pat. We have sectors, arcs, segments, all that good stuff. So we're going to make sure we understand what each of these pieces mean. So a part of a circle that is bounded by an arc and the end points joining its endpoints is a segment of the circle. So let's look at the segment. I have a part of a circle that's bounded by an arc and the arc's endpoints joining its endpoints. So if I join the endpoints inside my circle, I end up with a segment of the circle out here. And these are my endpoints and my centers here. So really it's just a piece, a specific type of piece that is cut out of the earlier piece that we found when we were looking at the whole sector. So the whole sector, or the pi wedge, a piece of it is called the segment. So we want a segment. In order to find the area of a segment, we have the entire sector, which is our pi piece, the entire sector minus the area of a triangle. Well, this area of the triangle is when I connect the endpoints of that sector. So if I connect the endpoints of that sector, I end up with a triangle. If I take away the triangle, I am left with this segment area. So it's a double step piece here. But we already have all the tools, so let's try one. What is the area of the shaded segment? So we're looking for just this area right here. We know that it's bound with its central arc, this arc here, AB, this whole sector. So I've got to find the entire sector, take away this triangular piece, and I'll end up with this, with the segment piece over here. So we want to use the formula for the area of a sector. We know the area of the sector, so I want to find this whole sector here first. I know the area of sector ACB is equal to the measure of its corresponding arc over 360. So it's ratio of the entire area, because we're dealing with the area. Substituting in the pieces we know, the measure of the arc is corresponding to its arc, central angle. So 60 over 360 times pi, and they gave us a radius of 18 squared. I use my calculator, make sure I have my algebra skills in place. I find out that this area of the sector is 54 pi. Inches squared. Okay. Then I need to find the area of this triangle that I'm taking away. So there's a couple things we got to think about. If this is 60 degrees on the inside, I know when I drop my apothem in, it chops my angle in half, so I end up with a 30 degrees out here. If I have 30 and 90, this one's automatically 60. But if I have a 60 and a 60, this one has to be 60. So I end up with an equilateral triangle. That's how I know this entire side length of the triangle is also 18. So the short leg of my 30, 60, 90 triangle is 9. because it's 60, 60, 60 makes me an equilateral. So this whole thing is 18, this whole thing is 18, so I end up with a short leg of 9. So we already know how to find this apothem business, because I know the area of a triangle is equal to 1/2 base times height. So I've got area of a triangle, 1/2. The base, the entire thing that it's perpendicular to, is 18. And I got to go find the height, which happens to be my apothem. Since the height is the long leg of the triangle, because it's opposite the 60 degrees, we know the long leg is equal to the short leg, rad 3. Short leg is 9, so I know the height is 9 rad 3. Using my calculator, I get 81 rad 3, what is that, inches. Squared. Now that I know what the sector, the entire wedge is, I can take away the triangle and I end up with my segment area. So I'm going to take 54 pi minus 81 rad 3. That would be an exact answer. So the area of that sector is, or segment, is 54 minus 81 rad 3. That's approximately, in my calculator, 29.3 inches squared. Alright, you've got the one below to try, and then you'll be done. Okay, there is your answer for that. If you didn't get it, rework it, check your notes, and then we'll see you in class.